Divide array into arrays with maximum difference. Medium, you're given an integer array nums of size n, where n is a multiple of 3 and positive integer k. Divide the array nums into n divided by 3 arrays of size 3, satisfying the following condition. The difference between any two elements in one array is less than or equal to k. Return a 2D array containing the arrays. If it's impossible to satisfy condition, return an empty array. If there are multiple answers, return any of them. Okay. Divide the array nums into n divided by 3 arrays. So you... Okay. So here there's 9 elements, so you have to divide it into 3 arrays of size 3, where the difference between any two elements in one array is less than or equal to k, so the numbers have to be close enough to be at most k apart. So like the elements can be the same as long as they're different indices. So like 1, 1, 3, 1, 3, 3, 3, 4, 5, 8, 7, 8, 9. Doesn't have to be sorted either, I guess. Here, it's going to be 6 size, so you need to have 3. You have to have 2 arrays, 6 divided by 3. You have to have 2 arrays of size 3 where they're 2 apart, at most 2 apart. Why couldn't this one be 2, 2, 2, another 2, 2, 2? Because they're 4 2s, there'll be an array with elements 2s and 5s no matter how we... I guess you can't distinguish 2, 2, 2 with another 2, 2, 2. So you can have duplicates elements as long as the combination of those elements is different. Yeah, okay, 2, 2, 2 is a permutation of itself. Okay, and then 2, 4, 5. So you have to have a 5 and you have to have a 2. And so you can't have a 2 and a 5 together. Okay. Interesting. So this one looks like there's 18 elements. So you have to have 6 arrays of size 3, where each array of size 3 has to be at most 14 apart. Okay. Kind of complicated in terms of setup. Well, it took me a while to figure that out, but let's go ahead and sort it up. I'm pretty sure sorting is going to be necessary for this one since it really requires the difference between any two elements. And I think you should be able to do this in one pass, I'm pretty sure. So the question is, like, if you construct 3 in a row, you can't have it to be you can have all 3 be the same, but then that would, well, so what I'm thinking is, if you have something where it's the second example, where once you sort it, it's 2, 2, 2, 2, 4, 5. In theory, what you can do normally would be, okay, let's just take that more simpler example. Let's say it's you can just construct it on the fly. Every three is a valid subarray as long as the first and the last is within K. So this is within K, this is within K, this is within K. You can just do a check there, like 3 is 3 less than and is this value less than or equal to the value that is 2 away? And if so, then that's going to be a valid subarray in your answer. And then maybe you have an additional check where you can only, for if the first and the last are the same, you can't have that thing be found again. So like this 2 goes to this 2, you can't just have another 2 go to another 2, because then that's an exact duplicate. But other than that, there's no duplication. So in general, if array at I is within K of array at I plus 2, value 2 away, in sorted array, and then subarray from A of I to A of I plus 2 will be valid part of answer, one of the valid subarrays for the answer. And if array I is equal to array at I plus 2, the value, that subarray, that kind of triplet subarray, can only be used once, even if multiple indices could form that triplet. So I just need to code that. I don't know why I press enter. Okay. Yeah. Turn a 2D array containing arrays if impossible, satisfy if impossible. So let's say we have an answer array, and then we'll just add arrays within that array to make it 2D. So I'll say I'll have a triplet. I'll also have a triplet set. So for each index in the range of n, where n is the length of numbers, I guess this should be, since I want index to be the starting index, I don't want to go out of bounds, so it would be n minus 2, because I want to go index plus 2 within this. If nums at index plus k is less than or equal to, no, it's greater than or equal to, nums at index plus 2, then this is going to be a valid subarray. So answer.append, I wonder what's the best way of constructing this. Maybe something where I just list the numbers. I can use a splice. Right. The Python syntax for this would be nums at index to nums at index to index plus 3. that would be just a way to splice from index plus 3 for the nums array. I also want to say if nums at index, whoops, I need to have the other condition first. If nums at index is equal to nums at index plus 2, so if it's a triplet deal, then and the value of that triplet is not in the triplet set that I keep track. Triplet set dot add this value and answer append this subarray. And that should be it. Actually, I just need to do this n times, right? Or n divided by 3 times. So we add the index, we add the triplet, or oh wait, this shouldn't be adding the triplet. If it's equal to, then I check if it's triplet. No. If it's equal to and it's a triplet, then I do this. Else, I continue and don't do this. Where doing this is adding it to the thing, and also, I guess this logic is kind of wonky. Maybe I should just say, no, this logic is necessary. Yeah. If the length of the answer, the number of subarrays, is going to be equal to n divided by 3, then return answer. After the for loop, if the length, well, after the for loop it didn't reach the answer thing, so then return empty subarray, empty answer array. Wow. Not even what? The syntax incorrect? I don't think so. Alright, let's go and just print out what my answer is before I return empty subarray. It was just strip empty. Empty. Nums index plus k is greater than or equal to nums index plus 2. Let's go with else print index not okay. So how interesting. It's only saying that 2 indices are not okay, so I would have thought this reached this thing. I would have thought it reached the thing. Print out the answer. Okay, this is hitting the continue. And nums index not in triplet. If nums index equals nums Oh, whoops. Okay, this logic is just full. If nums is equal to this thing. Okay. If it's not in triplet, then do this. Else continue. Boy, oh boy. Huh. So it's not possible. Odd. I mean, this seems like it's doing what I want it to. Can return any of them, right? Do 113 and 334. Why doesn't this work? Return TD rate is impossible status. Return an empty rate if they're multiple. Return any of them. 133 334. So that's my output. And here my output. Here my output is wrong somehow. This should have been. This should have been returning an empty array, but return 222 and 224. Wait, I thought this was only returning 2. Different ways to divide nums into 2 array of size 3 are 222, 245, 224. Divide, oh. Can you not use the same number? Fuck me. When they say divide, they mean you cannot use the same number in multiple subarrays. Okay. Well then, this is stupid. Like you just go 3, you have to literally just go every 3. Like there's no, well, what is the point? You have to go every 3. Jesus. Okay. Index from 0 to n going up by 3. If nums index plus k is less than or equal to nums greater than or equal to nums, then answered append nums at index to index plus 3. Else turn negative. Does triplet matter then? Alright, let me just do a quick check here. Can I just have all 2s? Like 2, 2, 2, 2, 2, 2. Is this just going to give me 2 arrays of triplet 2s? Okay. Yeah, this is just stupid. Like, this is kind of beyond simple, I think, unless I'm totally misreading this. And then here, if this thing doesn't work, then just return an empty array. And then return the answer. Okay, this is so fucking return empty array. Okay, well, this test case was not even necessary. Okay, I don't know why this was set up the way it was. It seemed, okay, anyways. So summary, yeah, best way of creating subarrays will be to just sort the array and then see if every 3 sized consecutive subarray can satisfies the condition elements within K, i.e. First element plus K is greater than or equal to third element. This I would consider this might consider this a greedy approach to finding the subarrays, because we're just like taking it as we go, not really considering the consequences. But since this kind of division of array into subarrays is kind of optimal, there's no need to have other checks. Like, there's no better way of dividing the elements into subarrays than using the sorted list. Like, yeah, the best subarray that you can get is like all the same, right? You're kind of minimizing your differences, and you'll get all the same when you kind of sort it and divide it into triples, assuming the alignment is fine. But so here, time complexity is going to be O of n log n to sort the array, and O of n to do a single pass through to have to check and create the subarray, 2D subarrays, or create, add the subarrays to the answer 2D array if it satisfies, if not immediately short circuit and return an empty array. Base complexity, this is going to be like this is, yeah. Sort, you don't even need a set of triplets. Go through every starting index of this every starting index of the 3-size subarrays. So it's going up by 3 each time. So 0 to n, going up by 3. Check. And if it doesn't work, if the check doesn't work for the starting index, or the value at the starting index versus the value at the third index, then just return whatever. Base complexity, this can be O of 1, since no extra data structure is needed. Like you obviously have the space required to return to the array of the appropriate size, but nothing else besides that.